Welcome. Today I'm going to talk to you guys about the continued discussion about speed. In the last video, 009A, I talked a little bit about how you can determine the speed that something travels over a wide range of time. We called it the average speed. But sometimes you really just need to know how fast something is going right at this particular time. And in mathematical terms, it's actually kind of tricky to figure that out. In fact, one of the reasons why calculus was invented was to answer questions like that. How fast is something going right now? It seems like it wouldn't be that difficult, but in reality it actually is. So we're going to jump to it. This one should be a little bit shorter video, I'm hoping. Again, we're at 009B speed. So we'll skip right to the one slide for this, and that is this one right here. The question it asks is, what about how fast I'm going right now? In the last video, I took a moment to sketch out a graph, and the graph looked something like this. I'm going to go ahead and draw it over here. On the vertical axis, I had how fast you're going right now. On the horizontal axis, I had time. And this origin represented where you live, your house, and this end of this horizontal axis represented you arriving at your friend's house. And I said, if you're going to map out how fast you're going at any particular time during that trip, let's say it's on a bike, you may see something that looks like this. If you do, let's say you accelerate, you get faster, and then you cruise along at a certain speed, right? And then you hit a stop sign, and you got to stop, and then you start up again, you cruise at a certain speed, and you're going right along, everything's great. And then you go to get to another stop sign, and then you get up to speed again, and then you end up finishing at your friend's house. Everything's good. So you can see that if I were to tell you that your average speed, just like I did in the last video, was 10 meters per second, can you see that that really doesn't tell you anything about what your actual speed was at any particular time? In fact, this cruising speed right here, and here, and here, is actually probably above 10 meters per second, but because you stopped and slowed down at certain points, the average speed is brought down to a certain number, in this case 10 meters per second. So maybe this was, you were going 12 meters per second, but because you had to factor in the fact that you slowed down and stopped, that lowered your average speed. And that brings up the point that I want to talk to you about today, and that is that this is actually an average. Now, if you were going to ask yourself, what's my average test score? So let's say your score is it's indicated with an S there. If I wanted to ask you what your average test score was and you had two tests, you probably, without thinking about it too hard, would know that you could add S sub 1 to S sub 2, or test 1 and test 2, and then divide them by 2. So this was a particular test taken at a particular time. This was a different particular test taken at a different particular time. And you could take those two, add them together, and divide by 2, and that would give you the average test score that you had for a class if you only had two tests. Now, is there an analogy, is there a relationship between these two things? And the answer is yes. This is an average speed, this is an average test score, and they can be treated in the same way. And so I want you to think about this for a second here. If I had an average speed, like my 10 meters per second here, I can then break that down into the addition of two speeds at particular times, and then the division of those two by 2. So here it is. Here's the idea. Speed at time 1 plus speed at time 2 divided by 2. So you can see these two are equivalent. They're basically the same The same formula, only this is for test scores and this is for speeds. Average speed equals the instantaneous speed 1 plus instantaneous speed 2 divided by 2. Now, there's some things that you want to keep in mind when you're looking at this. Number one is instantaneous speed 1 is a speed at a particular time, but it's the particular time, the speed at the beginning. Only at the beginning. Okay? And then, as you might imagine, v sub 2 is the speed right at the end. There we go. And so, if I know the speed at the beginning and I know the speed at the end, I can find the average of the two by adding them together and dividing them by 2. Why? Because they're averages. That's an average. That's what the definition of an average. So I want you to pay particular attention to this, because this is actually our second formula for physics, 2.2, right there. So on the formula sheet, it's indicated with a 2.2. It says the average speed is equal to the instantaneous speed at the beginning plus the instantaneous speed at the end divided by 2. That'll give, this is the relationship now between an average and an instantaneous speeds. Now, which one is more important? Which one is more useful? Well, I got to be honest with you. When I say speed, most people say, oh, like what you measure on a speedometer, right? So here's your speedometer, something like this. I have a Jeep, doesn't go very high up because it doesn't go very fast. So I assume your speedometer looks something like this. What is this speedometer actually measuring? And the answer to that is that the speedometer actually measures the speed that you're going at a particular time. Why would it not be helpful for a speedometer to measure the average speed? Well, if you take a look here, let's say in your neighborhood there's a particularly mean police officer who has decided that bikes can't go over 10 miles or 10 meters per second. Well, your average might be 10 meters per second, which seems like you're under the limit for the law. However, as we said just a minute ago, all of these red spaces right there, you are likely going faster than 10 meters per second, and it's only because it's an average and the fact that you were going slower at particular times that lowered it down to 10. And so would the police officer pull you over during these red spaces right here? Absolutely, because you're going over, at that one particular time, you're going over the speed that was set as a limit, right? That was the 10 meters per second. So a speedometer measures instantaneous speed. So when you see this word here, don't let it get confusing here. Instantaneous starts off with the phrase or the word instant. Instant, of course, just means at one particular time. So instantaneous speed is only the speed that you're going at one particular time. And how do you find it? Well, to be honest, if you watched the last video, you saw that I showed you a calculus formula. That's the calculus formula to determine the instantaneous speed. There are other ways to do it, but for right now, our main goal is to use this. First, we have to calculate an average speed, and then we can work backward to figure out what the instantaneous speeds are. So it's a little bit backwards, but it is a useful way of doing things, and it's easy to do things this way, in a particular special set of circumstances. So here's the circumstance I want to tell you about here. And this is really why this gets its own video here. So imagine you have a ball on top of a table above the floor. Okay? So it's resting on top of the table, everything's fine, no problems, right? While it's resting there, we would say its instantaneous velocity is 0. So v sub 1 equals 0. Let's say that the table is 1 meter above the ground. So if this were to fall, it would fall 1 meter. Okay. So the ball is going to fall 1 meter. We could then time out if we allowed the ball to drop, we could time that out. And let's say that's our delta x, right? Or delta y if you want. And then our delta t would be the time that it takes to fall. Now let's imagine that it takes half a second, which is way too long, but that's okay. So what would be the average speed for the ball as it falls? Well, we can figure that out pretty easily, right? If the change in displacement is 1 meter and the change in time is 0.5 seconds, we can easily go ahead and say that the average speed as the ball falls equals 1 meter divided by 0.5 seconds. Now, you may not see immediately what that is, right? But you can go ahead and do it pretty easily if you remember that this is actually 0.5 is actually 1/2. So 1 divided by 1/2 gives us 1 times 2, which is just 2 seconds. So, or 2 meters per second. So the average speed is 2 meters per second. Okay, so why is it important that I know the average speed when really I'm looking at this object as it falls? And I really have started talking about the instantaneous speeds right here. Well, here's how this works. If I know how fast it's going at the beginning, just at the moment it starts to fall, and I know how fast its average speed is as it's falling, I can figure out how fast it's going right as it hits the ground, v sub 2. Why? Because I have a relationship that relates those three things. I figured out that it's going 2 meters per second on average. I figured out that it starts out at 0 meters per second. And so what do I end up with at its final velocity? Well, that's easy enough to solve, right? So the average velocity, if I solve that formula, times 2, I'm going to bring the 2 over, right? Bring the 2 over to the other side. And then I'm going to get rid of the v sub 1 because we said that the v sub 1 was 0. And so what am I left with? I'm left with the final velocity here is equal to 2 times the average speed. So the final speed is equal to 2 times the average speed. What does the final speed have to be? Just before the ball hits the ground, that final speed must be 4 meters per second. You see how we can relate things together using this formula? We have to use the intervening cheat a little bit to use that average speed, but it is what it is. It does get the job done. So this is our thing that we want to remember here. And it is deceptively helpful, and it's going to come up pretty often, so you want to make sure that you've got it down. Okay, with that, I'm going to sign off here in just a second. Hopefully that makes sense. Make sure you're filling out your note sheet and your question form, that interesting question form and note sheet, both of which there's only one for 009, so since this is 009B, you can put your notes for this and the other on the same sheet if you'd like. And then your interesting question, you only need to submit one. Okay? Hopefully that makes sense. If you have any further questions, let me know. Don't hesitate to email if you're running into some problems. I can try to help you out that way if it's before 8 o'clock or so. I try to do my best to be available for that stuff. Okay, good luck to you. If you have any questions, let me know.